Hello class, this will be 7.1 part 2, now connecting sequences with series. So again, a sequence is a function that computes an ordered list. So for example, if a person earns $30,000 a year, receives a $2,000 raise each year, we can represent the sequence as it's going to start at 30,000, go to 32, 34, 36. Now, the total amount earned over these 4 years can be represented by the series, which is the 30,000 plus 32,000 plus 34,000 plus 36,000 to get 132,000. So a series takes your sequence, adds them all together. Some notation. So with a sequence, we saw was a sub n, where that sub n just represents the position for our term in our sequence. So this would be a sub 1 would be the first term, a sub 2, a sub 3, and we continue that on. Well, now a series is going to be represented by a capital S sub n, and so that's easy to connect series to the capital S. Now this is going to take the first term of our sequence, add it to the second term, add it to the third term, and so on. We can continue this and change it to what's called summation notation. So it's this Greek letter E. Epsilon is what it stands for. So this represents sum. So if you ever see this E symbol, all it's doing is taking your function and adding it all up. And so the summation notation, this letter E, is going to be used for a series. So again, if we have our series, that's a sub 1, a sub 2, a sub 3, all the way out to a sub n. So we're adding all of those up. So if I had s sub 5, it would only went out to a sub 5. But if I had s sub 100, it would have went all the way out to a sub 100. So now we can represent this with our summation notation. And so this big E tells me that I'm going to sum all of my terms out to some value n. So in this case, it could have been 5, it could have been 100, whatever n is going to be. And I'm going to start out with my first term is a sub I. And so I would read this as, well, I is really 1, so it's a sub 1, and that's my starting point. And then I'm going to go a sub 2, a sub 3, and continue that on. That I piece is called the index of summation. And do not confuse this I with the imaginary unit I. They are not connected at all. They can also use the letters J and K for this index of summation. So again, all this is really telling you is the starting point. Which term are we starting with? So I equaling 1 tells me I'm going to start with the first term. If I equaled 10, means I'm going to start at the 10th term and continue on. So 10th term, 11th term, 12th term, and keep going from there. So pay close attention to what your I equals or J equals or K equals. This is just telling you the term, and then the N here on top of our summation tells us how far we're going to go out to. So this N typically will have a number associated with it. So maybe N was 75. It tells me I'm going to go all the way out to a sub 75. Let's take a look at one of these. So if I presented this to you, so I want to sum k equaling 1, 6 on top, of the function 2k plus 1. So first off, what are my first 6 terms? Because that's what this 6 is telling me. I'm going to go out 6 terms, and I'm starting with the first term. That's what this k equaling 1 tells me. I'm going to start with the first term. So to find all 6 terms, I have to do this function for each one. So my first term is going to be found from 2 to the first plus 1. My second term would be 2 squared plus 1. My third term would be 2 cubed plus 1. Fourth term, 2 to the fourth plus 1. 2 to the fifth plus 1. And then finally 2 to the sixth plus 1. So that represents my first 6 terms that I'm working with. So for each of these, I could work it out. 2 to the first plus 1, that's just 3. 2 squared is 4, so that's 5, plus 9, plus 17, plus 33, plus 65. When I work all this out, I'm going to end up with 132. Okay, so the first six terms, 3, 5, 9, 17, 33, 65. The big E tells me that I'm doing a sum, and so it's going to add up to be 132. So my next slide, I said, what is the sum? When I work all this out, this whole piece, if I were to look at that, I can tell you that that is the number that it's going to represent is 132. All right, let's take a look at another example. So now I have my summation, j equals 3 all the way out to 6, and then it's a sub j is going to represent my function. If I wanted to write the terms, I know on this one, I'm only going to have terms from 3 to 6. My function is a sub j. So this would work out to be a sub 3. So I'm not starting at 1, I'm starting at my third term, plus a sub 4, plus a sub 5, plus a sub 6. Now, I do not know what my function a is, so I cannot sum these together to get a sum. This would be my final answer. All I could say it's going to be a sub 3 plus a sub 4 plus a sub 5 plus a sub 6. That's as far as I can go. Let's try another one. So this one has a lot more notation built into it. And the hardest part of these summation notation functions is making sure you understand which each piece represents. So I'm starting with I equals 1. So I know I'm going to start from the very first term on this one. And I'm only going to go out to the fourth term. So I'm going to have first term, second term, third term, fourth term. Now my function is f of x sub I, and then I have this delta x piece here. So we need a little more information on what all that means. Okay, so they're telling me my function f of x is going to be just x squared, and they're telling me that x sub 1 is 0, x sub 2 is 2, 3 is 4, 4 is 6, and that delta x piece is 2. So I needed a lot more information to be able to work this out. But now that I have this information, I can break apart the summation notation to actually use my function, add up all the terms, and find what the sum is. So the first thing I want to do, f of x sub I. Well, I know that I equals 1, so this is really f of x sub 1 delta x plus f of x sub 2 delta x plus f of x sub 3 delta x plus f of x sub 4 delta x. My f of x sub 1, f of x is this function x squared. So really, this is x sub 1 squared delta x plus x sub 2 squared delta x plus x sub 3 squared delta x plus x sub 4 squared delta x. Now I can start filling in numbers. Well, I know x sub 1 is really 0, so this is 0 squared times delta x, and delta x I know is 2, so this is 0 squared times 2, plus x sub 2. X sub 2 is 2, so 2 squared times 2, plus 3, which is 4 squared. So that's my 4 squared times 2, and then x sub 4 is 6, so this is 6 squared times 2. If I work all this out, this is 0. 2 squared is 4, times 2 is 8, plus 32, plus 72. I can add all that up to get 112. So this one, there was a lot going in with the notation, but they had to get us the second red line and tell us some information, and then it was just slowly substituting in each part until we only worked with numbers, and we ended up with a final answer of 112. So take a look. Part 2 in Math Excel, due Sunday, 4/26 by midnight. Email me with any questions. I'm available 10 to 11 almost every day. If you email me ahead of time, I can be available at almost any time as well. We can do email questions, we can do a Zoom chat, whatever you need, but continue working through these problems.